Well, hi there. Thanks for coming to my talk. I really like long titles, so that's what I have here. They often get shortened. There's even some that I've cut off of here. But what I want to go over is what I call a classic blinking cursor problem, which is there's some exciting new technology you have, and you want to figure out what to do once you get it set up, like what the point of it is, why you would be interested in doing it. So that technology in particular, as the title would indicate, is Kubernetes. Now, I think Kubernetes has been around for quite some time. I don't know, 5 years or so, depending on what you read and when that was written, because I guess that's how dates work. But you know, I'm more or less a developer-minded person. I've had a lot of other jobs, but I tend to approach things in the technology space from a developer perspective. And one thing I've noticed is this sort of I don't know if it's a paradox, but it's this contradiction in the Kubernetes world, which is you see all sorts of commentary like this, right? And some of this is, I mean, more or less all of this is helpful, but some of it is more helpful than others. But in general, what I've seen over the years is ever since Kubernetes came out, what we might call developers and, you know, application developers, also system developers, of course, but let's just say developers in general have been very interested in Kubernetes, and they've been, you know, trying to use it and stand it up and understand it. And I think, in a large part, we should probably credit developers a huge amount for the success of Kubernetes. I mean, at one point it was not a successful thing. There were many rivals, and then all of a sudden, all the rival platforms to it just sort of succumbed to the momentum of Kubernetes, which I think is great for us all. But then in the past couple of years, we've seen this sentiment like this, that like developers should really not pay attention to Kubernetes. Like it's not for them, essentially. And there's even more fun things like, you know, it's going to become boring and sort of meaningless, which is just a snarky way of saying that it will become ubiquitous and not such a popular concern anymore because it works and operates well. But I've been wondering recently, like if developers and by implication enterprise architects and, you know, sort of non-operations people are not supposed to pay attention to Kubernetes, then like, well, what are they supposed to do? What's a developer and an enterprise architect supposed to do with this Kubernetes stuff that they were passionate enough about over the years to actually make it the dominant new way of doing cloud native infrastructure? I think, as always with developers, it's always good to sort of go back to the basics and reassess what it is you as a developer should be doing. What is the goal that you have? How do you make sure that you can afford, you know, your weekly pair of toe shoes that you're going to need? Because I'm sure, you know, they start to get a little smelly. Maybe you can just throw them in the washing machine. I'm not sure. But so first of all, let's look at the basics of what I think developers should do. And again, I think this is very critical so that we understand the why of Kubernetes and how you should start thinking about interacting it, what you get from it, and the platforms that are built on top of it. So first of all, as one of my enterprise architect friends who lives here in London once put it, the job of developers is to move pixels on the screen. Now, of course, application developers, but this is a way of saying that if you're an application developer, you're writing software that conceivably people will be using. These people will have a task that they want to achieve. And the way that they'll do that is by using your software, using features in your software. And what that really means, if you think about it, now I guess this is for people assuming that they have vision. If they didn't have vision, you would be moving airwaves in the air or something. And if you're doing it through other sensory things, you would sort of induce the movement of whatever needed to happen to have a person realize that there was some sort of activity going on in the computer space. But we'll simple it down to moving pixels on the screen. But you're changing what the UI looks like, right? And what the UI looks like is changed by what happens in the back end and all of these sort of things, right? So you don't only do UI development, but to continue to the absurdity, you really are constantly thinking about how do I represent the workflow, the things that people are doing on the screen? How do I think about, you know, moving pixels on the screen? So that's the primary thing you're delivering is an application, right? Not necessarily like, you know, frameworks and builds, all this other stuff, as we'll get into. And what's the second thing that I think developers should be focused on? And I think that is put in this way, it's making sure that they're doing number one as efficiently as possible. And I think in recent years, in a decade or so more, I think the concise, helpful way that we think about this is removing waste from the process of doing one, right? And thinking about what are all the activities that we do other than programming that move pixels on the screen, other than maybe testing, like what's that core thing, those activities that we do that moves the pixels on the screen, and everything else, to use lean terminology, has no business value, if we will. How do we eliminate the time that we spend on those business value? Also eliminate bottlenecks. Wait time is waste. But I think let's start with, like, these are the things developers are concerned with. And as we look at an understanding of what Kubernetes is, and therefore what developers should do about a cloud native platform, let's always remember these two things. And if we're not shooting towards these goals, then that is why we shouldn't be paying attention to something, and we should look to sort of remove the waste of worrying about it. So I think a stretch goal that you have as well is, and this is kind of the ultimate goal that you end up having, why you're moving pixels on the screen, is you actually want to start thinking about, from the business side, we want to start thinking about product managing the business. We want to make the business programmable. We want to think every week, if we get the capability, how can we move pixels on the screen? What features can we introduce into our software that actually changes and improves the nature of the business that we're doing? And this is kind of the advanced sort of result of a developer, is you're helping the business side develop what they're doing. You are creating the product as embodied in the software that runs the business as well, which, is the topic of all sorts of discussion and digital transformation and things like that. So let's look at those two things. How do we move pixels on the screen, and how do we get to doing waste removal? Well, I think the most efficacious, or whatever, the best way to think about how you move pixels on the screen, how you think about creating that good, features that are actually good and useful for end users, that I see, is developers focus on, this small batch cycle, my simplification of it. And they think about, how can we get our deploys down as frequently as possible, let's say weekly, so that we can think of what is a feature that we could put in place, what is a way we can think about our software, how would we test out and measure if that was an appropriate feature, right? If we move the pixel around this way, do people use the software more efficiently, buy more stuff from us? And how do we learn from that so that we can adapt and change our software? We get this feedback loop in place where, because we're deploying a new feature every week, we can theorize and study if the feature actually accomplished the goals that we had. And if it did, we can go solve another problem. And if it did not, we can go try that problem again. You look at companies like Booking.com, and they run thousands of tests at any given time. They're constantly testing if their theories of how they move pixels around the screen actually help their end users achieve goals. Now, let me give you an example of how moving pixels on the screen, paying attention to if it's accomplishing end users' goals, and actually narrowing down to thinking about how you're really programming the business. A very seemingly boring, but a very effective example of that. And that is a story from Daimler, the people who make Mercedes, in addition to other things, talks about how they actually positively changed the business and improved the jobs that their users were doing. And that is, so there's a team over at Daimler that is in charge of the website where you go to search for and kind of build up your cars. It's the whole process of, if you're looking for a car, it goes all the way down to letting you browse the types of cars online, and then go book an appointment and other things like that at a dealership to hopefully buy one. So the scope they're looking at, the entire end-to-end processes, we as the team, the business we're supporting, is getting people to buy cars, right? And this team, in taking a very small batch of product-centric way to doing things, even they're developers, right, and product managers who are doing that. They had a site where you could search for cars, and they noticed that when they did an analysis of kind of looking at things that people searched for, what they noticed was that people were searching for vans a lot in addition to cars. Now, the problem was, on the business side, because vans were considered to be something that was a professional grade that plumbers paid attention to and other people like that, of course, it's a separate line of business. It's not in the kind of retail car space. So, of course, if you had an application that was intended to be to help people buying cars, you wouldn't have vans in there because this is a completely separate concern. Who's interested in buying vans? So this is a curious thing, that because they were operating in this small batch mentality, they had this product sort of way of thinking about things. They were curious, why are people searching for vans? What should we do about that? So they started putting some theories in place. They interviewed users, and they found out that, like our friends, the Kinesis here, there were actually a lot of people who were consumers, if you will, retail people who wanted to buy vans because they wanted to go on a summer trip, and they wanted to outfit a van to be a camping vehicle that they could go into, and on, right? So there were actually people who wanted to buy these vans. So after more experimentation, and I think it took a month or so to go talk with the business side, there was this phenomenal thing. This is the ultimate goal that you have with a product-centric way of doing software, where the development team was able to go to the van line of business for the sprinters there and say, you know, these people want to buy vans, right? We have evidence of that. So why don't we do an experiment and show results for vans, right? Even though we think of it as something that only plumbers buy, actual families and other people want to buy it. So let's put into production showing them search results for vans. And our theory is that people will be interested in buying those. So you run that through several small batches, and lo and behold, people are interested in buying vans. So you've really transformed the business around. You brought in new revenue that's very cheap for the business through applying this kind of small batch cycle and applying this idea of being able to program the business, right? This is one of those examples of one of the kind of ultimate realizations of good transformation that you're shooting for. So now let's try to bring that back to Kubernetes and development, and kind of look at how people achieve that. Now, I think starting to expand out from this idea of moving pixels on the screen, right, and kind of getting to that stretch goal of paying attention to product. The way that you start to achieve that, as I alluded to, is you really widen the scope of what you're looking at, right? Like you look at the full end-to-end process of what it means to move those pixels on the screen, to really change your mentality to this product approach, and look at how you're solving your users' problems, right? So this is, you know, in one way represented by what we in VMworld like to call the software supply chain, right? And you're constantly pulling back and back to think about, as long ago Damon Edwards and John Willis came up with, like what is the full end-to-end cycle from concept to ka-ching, right? Coming up with an idea and actually collecting the money for it. And, you know, if you're in government and other things like that, you can substitute whatever mission you're shooting after, but I'll just speak in commercial terms, because it's easier. But what is that full cycle? And typically with software, we're narrowing down a little bit here, right? There's not so much too much of the business development. But what you're starting with is an existing portfolio of applications that you have and new applications that you're looking to product manage. You kind of analyze what those businesses are, come up with theories of what to do. Like, for example, like we should try to sell vans if that's what people are searching. You product manage out a backlog, the features that you're going to do. You write some code. You know, you go through a QA process. You basically, you know, you're going to package things up in containers because that's just the way things are done. It runs through your continuous integration and continuous delivery cycle to get packaged up, and ultimately, hopefully, you know, this is a part that the DevOps world kind of brought to our attention, is you should deploy it to production, and it should run effectively. And as a developer, this is something nowadays you should be very concerned with, is until your application is running in production, I would argue that you have not done your job, right? Like you actually, until it's running in production, you're not focused on the full end-to-end thing. And then you're constantly looking at your end user to see if they're happy or things are not working out well, and you're kind of adjusting to what they want to pay attention to. Now, this all makes sense. Sounds great, right? But I want to raise this point because one of the chief things that when I talk with large organizations that they failed at is to take this idea seriously and actually analyze this full flow of what's going on, right? They haven't actually thought about the entire process of development, of doing software, means this entire flow, right? Like they tend to locally optimize and think about just one little component, right? The developers still think about coding and developing features. You know, business people, if you're lucky, you're kind of thinking about product management. And definitely, you know, operations people tend to still think about their own world of doing things and don't think all the way back to the developers. And, you know, the companies aren't taking the more all-in holistic view of things going on. And just as a proof point for that, I mean, when you look at surveys of just never minding continuous delivery, but if you think about that whole pipeline, that whole supply chain, there's actually a small amount of organizations that even have continuous integration in place, right? And this is my estimate based on about 5 or 6 years of observing various surveys that are out there and kind of looking at more recent ones from places like Forrester. But you start to understand that, if we're, you're not going to really deliver on that full pipeline. You're not going to be able to get to those weekly deploys if you don't have continuous delivery, and you're not going to be able to get continuous delivery if you don't have continuous integration. So I want to start there with what developers should care about with Kubernetes and why it matters for developers and why the cloud native platforms built on top of it start to matter, why it's good to pay attention to that. Now, I'm gonna take, for developers, I'm gonna use this word that I don't think they like. People call it the G word, and that is governance. And I think in particular in large organizations where you have hundreds, thousands of applications that have evolved over decades, right? The way that you achieve scale, the way that you optimize and pay attention to that entire process over thousands of different applications, hundreds of different businesses that you're operating, is that you really use governance as a way to do waste removal. Now, governance, to my mind, what does governance mean? It means a couple of things, but what I'm primarily interested in is governance as standardization, right? So instead of having a bunch of different variable ways, let's imagine that you have, we can use Air France KLM as an example. They have over 2,000 applications and services that they're managing, right? Including, as they were telling me recently, they have one application from 1968 that is running on a custom-written operating system. That's kind of one of their core processes, right? So if you think of that as the extreme end of the gradient, all the way to the wonderful mobile app that I use all the time when I'm flitting about here, they've got everything, right? And they're not unique at all. Large enterprises, that is a snapshot of what they look like, right? They've got thousands of applications. And if you think about over the years, the variability that's introduced in the way those applications not only are written, but the way that they're run, the way that they're packaged up, the way that they're managed, that causes a huge amount of waste in the system as you hop between these different ways of doing things. And I think what you need to start thinking about from a governance standpoint is, how can we introduce enterprise governance that is going to remove that waste and standardize the way that we're doing things so that developers can more and more focus on just moving the pixels because we've optimized that entire delivery chain, or at least we've optimized the part that we can with a cloud platform, right? So the theory that I've been developing recently is that putting a cloud native platform in place allows us to put that governance in place, to do that standardization, which allows us to remove a significant amount of waste from the system, from that end-to-end process, which allows us to focus on moving pixels on the screen, which allows us to put a product management standpoint in place so we can start selling Sprinter vans to the Kinesis so they can go enjoy their vacation, and we can make some new free revenue in the way we're doing our car stuff. So let's look at how this theory, how something like Kubernetes and the platforms you build on top of it really help deliver to that. Let's look at what Kubernetes means for developers in this context. And also this is a good excuse to use some of my favorite vector clip art. But if you look at Kubernetes, like at its core, what it's doing for you is once you've containerized your applications, it's going to figure out how to orchestrate them, which is to say, put them in a bunch of VMs, put them in a bunch of nodes, as it calls them, configure all of the networking required for those containers to talk with each other, but also to talk to the outside world, do all of the scaling up and the scaling down that you would need, pass in the configuration at runtime, do a lot of really great, and this is one of the strengths that I think, for example, over in the Cloud Foundry world, we've been talking about this kind of thing for a while, and I think we'll start to see this year as more and more Kubernetes sort of based platforms come into play and applications come, we'll see the huge benefits that you get from the release management things that something like a cloud native platform has, like rolling updates, being able to do blue-green deploys and run multiple tests in production like Booking.com does, as I mentioned. But the way that release management happens with something like Kubernetes is really pretty magical and done well. So the point of Kubernetes is, if we're running everything in containers, how do we actually not only release that and run it in production, But how do we specify what that looks like? How do we package it up and manage the injection of configuration into it, right? And the alternative to this is doing a lot of sort of scripting and automation and worrying about how builds are propagated through the system and deployed and installed in production. And Kubernetes looks to really solve a tremendous amount of stuff with that with you, and also run it in production. And hopefully what you can start to get to here is this is a standard for how you not only run containerized applications in production, but how you describe them and package them, and key for the developers, how you design them. And it has implications of how that should be operating. Now, I'm going to get into the implications for that, but just to quickly reference it, if you want a much better explanation and much more in-depth, these are at least 3 resources I would point you to. If you want to get a copy of these slides, you can click on these things. I think, you know, the Kube Academy that we at VMware have out is a great general introduction to a lot of the concepts here. And these 2 books, the up and running one is just as it always has been, a very broad overview that goes over all the different aspects with lots of examples. And I think if you want a more philosophic sort of treatment of cloud native infrastructure and you know, Kubernetes, you can get that other book there. So let's start off with the implication for developers. I think the first shift, as I was talking about, is a lot of what Kubernetes wants you to do is think about how you package up, and therefore how, from a developer standpoint, how you're designing your applications, what the interaction model is. So this is the first thing that I think is good to take seriously, and that is that you're going to be building distributed applications, right? And, you know, I think for a long time, we've been developing distributed applications, but sometimes we don't, right? Like we have these single process, monolithic applications that basically run in one process and kind of operate in that way. Whereas distributed applications are smaller components of applications that are broken up, that are talking with each other over a network, right? So there's a lot of networking going on, a lot of service discovery going on. So think about the patterns of distributed applications, right? And from a technical standpoint of view, what this means is that you're packaging up each little component as a container, right? It's kind of container-oriented development. And what we mean by that is that essentially you're going to have a single process application for the most part. And this single process thing does one thing really well, right? It's a component that's going on. And then, of course, if you've got all these single purpose applications running in their own process, running in its own container, you need to kind of think about how you network things together, how they find each other, how they sort of manage who has access to whatever, but then also how you kind of coordinate it and bring it all together, right? And in summary, what you're working on are microservices. And, you know, I'm not so interested in the meat stack, the meatware side of microservices, where you have these separate teams who don't have to work in lockstep and things like that. I mean, that's a great goal to achieve. But I think you could probably spend a significant amount of the rest of your developer life just achieving the technical aspects of microservices, where you figure out how to break up your application and have them coordinating with each other. And then, you know, you can be doing microservices, and that'll be wonderful. So this is the first thing as a developer you need to think about is, if I'm running on Kubernetes, I am now doing distributed applications. I'm now doing microservices. And I'm thinking in terms of components that are in containers, and I need to break up my application to do things that way. Now, this, of course, implies that you're going to be building a lot of containers, right? So, you know, currently, at least in the Java world, in the Spring world, you're constantly building jars. You're building up Spring Boot jars, right? So that's kind of your unit of containment that you have. You know, it used to be you would build up ear files in the Java world, whatever your sort of unit of building things up was. But now you're building up containers, which means you're building up an operating system on top of it. You're building up the frameworks that you need. You're thinking about how are these different things within a server, within a container, operating with each other. Like, what ports do I open up? What networking do I do? And this is really a whole lot of fiddly stuff. And if as a developer, that's part of your application, now you're in charge of all of that, right? When new releases come out, when you have new policy, when you've got to update patches, these are things you need to manage as well. You know, if you're running your JVM, depending on what version you are, most people from what I can see, they tend to run Java 8 or kind of older versions of Java. You've got to make sure that you've tuned and configured your JVM to do things correctly. So it's a new set of concerns that you need to have because you're deploying in a container way. And I think what you see emerging as a best practice is don't build your own container, right? Or at least have a tool that you wrap around it. And there's many tools available that really automate this process. And if you want to be really tricky as a developer, you kind of go to the ops group and have them take care of that for you, right? Have them be the ones who are responsible for building containers for you, which is giving up a little bit of control, but your life will be much easier if you're not so much concerned of handcrafting your containers and worrying about managing that over time. In Kubernetes, there's this notion of a pod. And a pod is basically a way of wrapping around one or more highly related containers. And, there's a lot of pods are a pretty simple concept once you spend a lot of time understanding them, being kind of ironically speaking. But start thinking about if you're packaging things up into containers on a pod scale, right? And mostly it's a one-to-one mapping, but as this advice from Kubernetes Up and Running says, like if you have a couple of different processes that only can operate together, right? If they were on a different server and they would break, then they probably belong in a pod. But for example, you can always run a database on a different server, so that should not be in the same pod as your front-end process, right? Like the canonical example here is if you have a web front end that's serving up static files, and you have another process that's always monitoring and downloading these static files from a Git repo or whatever, those probably belong in the same pod. But it's important to think in terms of pods instead of containers, because pods are the unit of control that Kubernetes have. So whenever you get to scaling up and scaling down, whenever you get to configuring things, pods are that unit that Kubernetes is going to deal with instead of directly with the containers. So think of them as kind of a wrapper around your containers. Furthermore, into packaging, right? There's a lot going on with packaging things in containers, and this is part of the benefits that Kubernetes has, and part of the annoyance, as always, that comes with a beneficial thing. So of course, there's a lot of YAML, but you want to think about from this pod perspective. So I'm describing what a container is. I'm describing how containers are grouped into pods. I'm describing how pods result in a deployment that I have. So when I actually run this thing in an environment in production, how are they laid out? How do they? What networking do they need to know to talk with each other? What relation does this application deployment have? And you model that all out in the deployments that you have. Kubernetes would call it an object. And then on top of that, you're also talking about, so as far as our configuration goes, what configuration do I need to have in the application? How do I kind of pass that in? And what variables am I passing in? And we'll talk about externalized configuration a little bit. But think about how you're packaging up the application, what it's going to look like in production, right? You're not only creating a jar file or kind of a build, you also are now thinking about what does the deployment look like in production. And also you can do things like think about the release strategies that you want. So when it comes to a deployment, how do I want not only scaling to be done, but how do I want my rolling upgrades to be done? What way do I want this software released? So this is something that you can share this responsibility with your operations team. But if you're using something like Kubernetes directly, you want to think about, all right, now I'm in charge of this release plan that I have. So you start thinking about what this packaging is and what does that end up looking like. And to give you, this is from the Spring Music Store, if I remember. But, this is kind of a sense of like the mapping that you'll be doing. And we'll get into what these probes are in a little bit. So that said, there's a couple of things as a developer that are sort of like must that you need to do. These are things that Kubernetes is expecting as far as probe interaction with your containers, with pods that you're going to have. Now, some of these are convention and other ones of them are direct things you need to implement. And a couple of them, so if you look at the life cycle of how Kubernetes is running your containers, your probes, what it's going to do is it's constantly monitoring the state of your apps, of your probes, your containers, and seeing if it's good, if it has liveliness or health. So you actually have to implement, it doesn't know what the answer to that is, so you have to go into each of the containers you built up, each of the pods, and define basically like I'm good, I'm not good, and I forget the third criteria. It's kind of like I don't quite know, but you have to define how it can do its own health check, and then Kubernetes will come along and check on it. And if it's unhealthy, it will destroy that and create a new one based on the way you've described your deployments, right? So when you are breaking up your application into all these different containers, describing them to Kubernetes and pods, you're going to need to implement these probes. A probe that will determine if your app, the little chunk that you have in your pod, is healthy or not. And if it's not healthy, it'll get restarted. You also define the readiness probe. And the readiness probe says that it's ready to be used. And then the startup probe is, it's that the container is starting up. It's booting basically, and it returns that it's in that process. So you can think about the life cycle Kubernetes is going through, right? Like it's going to start up a pod, it's going to and see if it's starting up successfully. It's going to poll it to see if it's ready to be used, and once it's ready to be used, it's going to start using it and direct traffic to it. And then periodically, it's going to go in and see if it's in a healthy, good state. It's going to ask it if it should stay alive or it should be killed and restarted. So these can be defined as URLs. So Kubernetes will call into a URL. They can be defined as commands that get executed, I think through SSH, probably something different for Windows, but just you can execute commands and return what it looks like, or they can be, I think, through direct network connections. But these are things you need to define as far as healthiness or not. Now, there also are some hooks that it will call into to tell you when, kind of the life cycle, if you need to do something when it started and right before it's going to be stopped, right? So you can do some graceful shutdowns. And then finally, I mean, this is not so much of the life cycle, but logging is done just through standard out and standard error, right? So it's very important for the way that Kubernetes functions that you log all your stuff out to there versus like logging services or actual file logs or things like that. So this is just kind of a checklist of basic things to implement. Now, I mentioned externalized configuration, which is a core concept of Kubernetes, right? And it has been in many places, including the Spring world, a core concept for a long time that you don't ship configuration and you figure out a way to inject it in there. Now, Kubernetes really standardizes how this is done with a concept called a configuration map, which is effectively, you can think of it as a service where you can inject or check in configuration that you want for your pods and your deployments and say, this is for this version of this deploy that I have, give it this configuration for this, so forth and so on. And this configuration through various means is provided to the pods that you're running, right? So you need to think about, if I'm writing my application, how do I almost need an API, a process for bringing in the configuration that I have. And I definitely don't want a hard code thing, and I don't want to ship with files that I have that in each deployment. I'm instead going to use this configuration way of externalizing the configuration. Now, the way you access that is you can access it whenever the container starts up within a pod. Kubernetes will set environment variables for that, but it also can write out a file in YAML or JSON, if I remember, in a known place for you that your application, when it starts up, can suck in this file, look at the environment variables, and get that. Now, if you use a framework like Spring Cloud Kubernetes, there are other ones that kind of just hides all of that from you, and you bring in your properties or your configuration through the usual method you would be used to in a Spring world. But again, think about how you externalize configuration and how in the life cycle you start up, you read in that configuration and start things up. So there's a whole lot more of what Kubernetes does. There's that even as a developer you need to think about is the storage concerns that you have, because if you need to have persistent storage, you need to configure for that. You need to think about the network routing that you have in, north and south and east and west, in from the outside world and amongst the different components, and plan for and describe what that looks like. Of course, there's going to be load balancers and secrets, certs and passwords and things like that. And then you can get into a dizzying array of, we used to call these proxies or, even facades or things like that. But you can use all sorts of, the way you divide out the functionality that you can have, there's a very common pattern of, instead of doing it in the primary component, you do things like logging and even kind of administrative stuff in a sidecar, and you can really attach onto the Kubernetes lifecycle with handlers. So there's a lot of stuff that you can get involved in doing. So now let's look at the other thing I spend a fair amount of time focusing on because I think it's very helpful, and that is the role of enterprise architects. And I think what I want to think about with Kubernetes, what enterprise architects should think about, is really thinking about enterprise architecture as code, right? Thinking about shifting how they think about their job and what enterprise architecture is and what enterprise architects do as the same way that we think about infrastructure as code, right? Automating and programming things with all sorts of cloud-native platforms. How can that governance and enterprise architecture be expressed and implemented in a programmable way as well? So the first thing, again, is that, so if you have that kind of rudimentary understanding of Kubernetes, right, there's a lot of standardization of how things are done, but hopefully you can also realize there's a lot of variability that gets introduced in how you implement those standards, right? So I touched on one of them, which is building up containers, right? So you can kind of do whatever you want in a container, and Kubernetes doesn't really care. But you as an enterprise architect probably do care, right? And while there are standards and conventions, kind of, sort of how you would do service discovery and manage configuration injection, you very quickly get to the point of how the conventions and the practices that developers will be following are not really standardized in Kubernetes. Now, there's all sorts of service mesh things and all sorts of frameworks that are introducing standards there. But what you're going to end up doing, what your developers will end up doing, is creating a platform on top of Kubernetes. And this is where that idea of a platform for platforms comes with, right? And it's kind of diagrammed here in that, like, the infrastructure stuff is standardized, how you orchestrate and deploy, containers or pods onto VMs, and how those are scaled up and scaled down, how the configuration is handled, secrets. Like, there's kind of a base platform that is provided there. But how they actually implement all the microservices stuff that you would want to do, how they handle streams and events and things like that, what you're going to find very quickly is that if you don't introduce governance and standards with that, the developers are just going to run wild and do whatever they want, right? And you're going to be right back in that place of variability that you were in. So one of the first things you want to do as an enterprise architect, and I don't think this is a traditional thing that EAs necessarily have done successfully or do nowadays, is really think about what platform can we put in place? How can we standardize that? Now, in the VM world and Pivotal world, we've been doing this with Cloud Foundry for quite some time, right? Which layers on top of cloud native platforms like Kubernetes and has a very opinionated, set way of putting a platform and a piece of governance in place rather than letting people just run wild with it, which is definitely something worth looking into. If you're interested in that approach, or you can look at other options, build your own sort of platform for it. But as an enterprise architect, focus on building a platform to enforce your governance, not just a bunch of Word docs. Now, a practice that I've noticed and that we've noticed over time is that oftentimes enterprise architects have said, for example, use this ESB, right? Like they've enforced a platform of governance before, but it's really fallen by the wayside because it doesn't evolve very much. And I think sounds very nuanced, but they haven't introduced the idea of product managing that platform for their developers, right? Instead of thinking about, we're introducing this platform, and it's a way of enforcing our governance, so it satisfies the needs that we have as enterprise architects. They haven't really spent enough time product managing it and thinking about who are our customers. Our customers are those development teams. So we should always be evolving this platform to match what development teams are doing. We need to product manage that platform and constantly be innovating and developing it so that those developers don't think that the platform we have is stagnated and they go off and do their own thing and they introduce variability and break the whole point of efficiency through governance. And so I've seen companies like Rabobank, Home Depot, and Comcast, and all sorts of companies that have really taken this idea of platform as a product, and it allows them, if the enterprise architects are running and building a platform and actually evolving it, even on a weekly basis, to include new technologies and always trying to help the developers, they actually get developers using the platform instead of complaining about it and working around it. And there's quite an extensive presentation I and other people have that goes over more of what this concept means. So finally, I want to wrap up with what I think for most large enterprises is one of the most critical jobs for enterprise architects to focus on, and that is really thinking about, now don't fall asleep here, is really thinking about how they're modernizing their portfolio. This is something that is in particular very important for large enterprises, the kind of people that I talk with. And unlike, your Spotify's and even your Netflix's and kind of tech companies that we learn a lot from and try to pattern ourselves in the enterprise space after. I kind of alluded to this with the Air France KLM case, but this comes up with every large company, especially, banks, governments, all sorts of places like that, is there's been years of mergers and acquisitions. They've built up a lot of technical debt, and there's nothing wrong with debt. Debt is a lot of how progress is done, but eventually you have to pay down that debt, right? So if you build up technical debt of quick technical decisions that mean you can release something faster than it would take to do perfect, you're going to have a huge amount of that. And you also just have old business models that have kind of like not really adapted. And this really creates a huge amount of drag in your portfolio, right? So oftentimes when you're trying to do something new, you're trying to just add a new feature in an app, you kind of unpull that and you find that it takes a long time because you have to go all the way back to some archaic systems, right? And this often comes up when you try to get the hollowed unified view of a customer and you've got to integrate with all these ERP and CRM systems. So I think this is very important because what you'll find is that, to use my friend Paul's one of his quotes, right? Like, you can put any garbage you want in Kubernetes, right? So if you're just moving your applications over there without modernizing them, like whatever, you can just put junk in there and it might work, but you're not really going to get benefits and you're not really taking advantage of modernizing things. So I want to go over a little bit of the strategies that I've seen people doing for portfolio management. And I think one of the most important things is thinking about how you're setting your expectations, right? If you've got thousands of applications, it's going to take many years to modernize them, right? So whatever anyone is going to tell you, you can't like just modernize them overnight or, even within a couple of months. You really need to put a very deliberate process in place, probably more work than you're used to doing, to really assess what that portfolio is. Think about applications, the low-hanging fruit that can be easily moved over. They're likely things that are already, for example, in the Java world, like Spring Boot applications or have some of the lighter profiles. But on the other end of the spectrum, you'll have like, Visual Basic 6 applications, right? And those are things that, like, while vital, are going to be a lot harder to move over. You probably just need to rewrite those kind of applications. But also, one of the key aspects that I see companies, again, like Air France KLM, who I recently did a webinar with talking about this, they have a very business-centric way of doing things, right? Where you analyze the portfolio from a technical fit, but then you also want to analyze it from a business fit, right? Like, is it going to matter when we move things over? Is this going to have a big enough business impact for the resources we're going to spend on that? And I think there's a couple of other key insights that they and others have had, is that you also want to set up kind of like the business case and measurements for moving that, right? So when you move an application over, you want to measure if it was successful. Again, it's kind of back to that small batch loop thing. Put in place ahead of time, how are we going to determine if this was successful or not? And that's key not for just rating yourself, getting that red, yellow, or blue status report somewhere, but actually evaluating and improving how you're doing things. If you're measuring how one project went, when you get to the next project, you can retrospectively think about what worked and what didn't work and change your strategy, your approach to match that. So I would start off with some simple applications, right? Store finders, for as annoying and small as they may sound, are actually great applications to start with, right? Like, you just want to locate a store somewhere. So think about applications like that that are used frequently, that are probably not really very good, that have been ignored for a while. But if you actually help people find stores quickly, right, maybe match it to inventory that's in that store, you start to develop these things, you'll not only get a sense of technically how to modernize something, but you'll start to understand the benefit of modernizing and start to get all sorts of other cases, success to kind of build up momentum for doing other things. Now, a company like T-Mobile, for example, they've also modernized like a single API method. In their case, I think to check the sort of billing status of various customers. I think I'm getting that wrong, but they found this one method that was called all the time very frequently, and they modernized that to do basically a customer check on things. So find these small scoped but very business critical things and start with those and kind of evolve over time. And then also it's good to start to maintain a cookbook of common patterns that you follow and things that you do. We have a good starter cookbook that a lot of people start with, and then they expand it out and evolve it on their own. I think it's worth your time going through all of this, right? Like over the years, like large organizations I've studied, right? These are just some picked out improvements that come from paying attention closer to what developers do, really optimizing the way that they're doing it, removing waste from the system using a cloud platform, and then also modernizing the way that they're doing things in a very deliberate, disciplined sort of way, right? Like you can see huge improvements on the technical side, but more importantly, more importantly, because like the more business success you have, the more like latitude you'll have, and the easier your life as a developer and enterprise architect will be, and also you'll be doing a good job. You can see that there are actual very material improvements to the business side of what you're able to achieve, right? So going through all of this, really following those disciplined approaches does pay off, and I think it's proven through numerous case studies that I've definitely seen over the years. So with that, this is me. If you don't know, I've written a couple of booklets that go over a lot of this stuff, not the Kubernetes stuff so much, but from the sort of business angle of things and how you change organizations over. If you're interested, I do a couple more podcasts. If you're interested in those as well. Thanks for sitting in and listening here. I'll see everyone around next time. Bye-bye.